preprocessing. So let's just start up opening a new notebook. And we're gonna use also the vehicle data sets. This time we will use the car details, the V3. Okay, so let's just start with importing our libraries. So we're gonna import NumPy as a NB, and then we're gonna import pandas as a BD, and finally from sk learn dot pre-processing, we will import the label encoder. Now let's call this one V3 or V2 as you wish. So this is bd dot read underscore CSV, and now we're gonna put the name of the file. So this will be a car starting with capital letter. This is a case sensitive. Details v3.csv. And to make sure we have done it right, so let's see how the data look like. So v2.head and see how it goes. So we can see we have a more values here. So we have the name of the car, the manufacturing year, the selling price, the fuel. I assume it will be the same thing we have portrayed in the previous one. We have the seller type, the transmission owner. Now this is a new one. So we have the mileage. I think this should be mileage per kilometer. So not sure what is this one here. So this is the kilometer driven. I think this is the kilometer per liter. Yes. So this will be kilometer per liter. So mile per gallon in US units. We have the engine size. So this is also cubic centimeter. This is horsepowers, and this is torque. So when we take a look here, so we have maximum and the torque, which you will be think they are really correlated. So we can drop the torque, I guess. So let's drop the torque here. So V2 drop, and we're gonna drop the torque in axis 1 and in a place equals true. Now we know that we can handle the other ones similar fashion. We have done it before. So we can see V2. Now seller type underscore type would be equal to, okay, we need to define the function for the label encoder first. So label underscore encoder equals label LABLE ENCODR, and then open and close banana bracket. So this will be equal label underscore encoder, and then we're gonna open or dot fit underscore transforms transform. Then for the V2 for the seller type. Then we have also V2 transmission. So V2 transmission, and this is equals to label underscore encoder dot fit transform, and we have also V2 with transmission. What else? So also we're gonna do it with the owner. So let's do it for owner. V2 with owner, which is equal to label underscore encoder dot fit underscore transform for this one. V2 for the owner. And I want to see how it look. Hopefully I didn't mess up. So I made some typos here. Okay. So these are now is easier to be handled. Now we're gonna do for the fuel the same way we handle it in the previous section. So we're gonna drop it first. So V2 dot drop. No, before drop it, let's make a dummy variable V2 dummy. Okay, which is BD dot get underscore dummies, which is DUMMIES. And now this is going to be done for the V2 for the fuel. Now, after that, we're going to drop this value. So, or this variable V2 dot or equals V2 dot drop. And we're going to drop the fuel for axis 1. And then afterward, we will contact it. So V2 equals BD dot concats. And now we're going to address the matrices that we're going to put them together. So V2, comma, V2 dummy. And on axis equals 1. And run it. Let's see how it look like. So V2 dot head and run it. So it worked perfectly. Now we have a problem. Let's say we are building a regression model and we want the regression model to handle this value, the mileage or the engine or the maximum horsepower. So this is alphanumeric value. which is will be treated as a string, so it will not read that. But we don't want to delete that totally. We just want the having the numerical number here. So we want to extract this information. So let's do it now for the mileage. Okay, mileage per gallon, or in this case will be kilometer per liter. So V2 for mileage equals will be again V2 and mileage. Now we can put dot str dot extract. Now we're gonna extract the digits. So open this one and this one again. D plus S type float. Just for a trial, let's see if it works well. And this time I want to see it in the tail. So it's extracted this value here smoothly. There is no problem with that. Now let's do it again, but this time for the other remaining values. So we're going to do it for the engine and the max power. So this is engine, which is equals to V2 engine. Now dot str dot extract. Now open this parenthesis and we're gonna do it for digits. So backslash D plus and then dot as type, and the type will be float. Of course, you can put integer if you believe this is an integer. Now V2 also this time we're gonna do it for the max power. So max underscore power will be equals to V2 max power dot str dot extracts, and then open this banana brackets D plus dot st lights. I think this L was as type float. And run it. Okay, so let's see how the data look like now. I want to see the all over data. So V2 dot head, and I want to see 50 columns here. Well, let's see how the size of this data. So v2 dot shape. So it's bigger than the previous one. So it's 8,128. Now let's see how some of these values look like. Heads and 50. Gonna run it. So we have some missing value. Here. Okay. Since we are playing with the regression for instance, we can do this fill with mean. So we can say v2 now for the mileage equals v2 dot v2 mileage dot fill na v2 mileage dot mean. And we're gonna redo it again for the engine. So v2 and engine equals v2 for the engine dot fill not value for v2. Again, this is would be okay. I think it's not for the engine. It should be, yeah, it's for the engine dot mean. And we're gonna do it again. So mileage, engine, maximum power, and seats also have this issue. So V2 for max power equals V2 for max power fill NA and V2 and max underscore power dot mean. And we're gonna do it for the seats. I think this parenthesis is wrong, should be goes there as well. This one here, so as the first one. So V2 seats, see how it's right, seats or seats? Seats equals V2 seats dot fill NA V2 seats. Dot. Now I want to use the median for this one. Let's see if there's any other problems with the variables. So everything looks good now. So we're gonna run it. I think we have an extra one here. So let's see how it look like. Head 150 item. So it looks way better. And now we can handle this data either using any kind of machine learning technique. Okay, so in next lecture, we're gonna start reduction techniques such as BCA and SVD. See you there.